Let's assume you have two classes. Both scored exactly 610 total marks on their math test. Does that mean they performed the same? Not quite. Section A has 10 students, while Section B has 12. To find the truth, we need measures of central tendency, a single value that represents an entire set of data. Today, we aren't just looking at numbers, we're finding the heart of the data using mean, median, and mode. Let's bridge the gap between messy data and clear insights. Welcome to my new lecture. Today we're going to be talking about the measures of central tendency. In this unit, we are looking for a better representation of data. The purpose of summarizing a data is to draw meaningful results, to analyze the data, and to compare two or more data having the same characteristics. When our information has been arranged into a frequency distribution, then our information contained in it is easily understood. It becomes clearer when it is represented by graphs. But we need a simpler way to represent our data in a more efficient way to analyze and understand better. So, this is our case study. Consider the test scores out of 100 from two different sections of a ninth grade class. We have section A with 10 students and section B with 12 students. We need to check which section performed better. But just by looking, it's hard to tell. We need a simpler way to represent each group with a single and meaningful value. Finding our center. To summarize and compare between our data sets, we use measures of central tendency. These are single values that represent the center or a typical value of a set of a data. They are also termed as averages or measures of location. The first measure of central tendency is the arithmetic mean. It is the familiar average which balances all values. It's basically the ratio of the sum of values of a data and number of values. That is known as arithmetic mean. While the median is the exact middle point that splits our data in half. And the mode is the most frequently occurring value in our set. Now, each of these tools gives us a different perspective on the center of our data. Tool number one, which is the arithmetic mean or average. It is the ratio of the sum of all values to the number of values. It's the most common measure of central tendency. So this is the formula and it is for ungrouped data. We can write arithmetic mean as x bar and that is equal to summation of x over n. Summation of x, what does this represent? It represents the sum of all the values, while n represents the number of values. If we apply it to our case study, let's use this mean to compare the student scores. So if we look at section A and count all of the scores, which are the class intervals, we get 610. And the number of students are 10 in section A. So we can use arithmetic mean, which is x bar being equal to summation of x over n. That means 610 over 10, so that is 61. Looking at section B, their sum of scores is also 610, but the number of students is 12. So we can just write 610 divided by 12, so we have 50.83. Now, this concludes that since 61 is greater than 50.83, the average performance of section A is better than that of class 9 section B. The mean for group data. What if our data is already summarized in a frequency table? That means if it is already grouped. We can still calculate the mean, but using class marks and their corresponding frequencies. By finding out the class marks, we know that that is x, and the number of students, that is f, which is our frequency. So when we multiply both of them, we get f of x. Here, the mean for group data is summation of fx divided by summation of f or n. F is the frequency of each class and x is the class mark or the midpoint of each class, while summation of fx is the sum of the products of the frequency and class mark. And summation of f is the total number of values. It is just equal to n. If you look at this example here, we have the student marks in a test and we need to find the mean for the following data. Firstly, we will find our midpoint for the classes, which means if you add the lower limit with the upper limit and divide by 2, you will get your midpoint for your class. When you get all of the classes, then you can multiply them with your frequency and add it all together, so that will be the summation of fx. And adding all the frequencies together will be equal to the summation of f, which is 25. So we can write x bar is equal to the summation of fx, which is 725, divided by the summation of f, which is 25. So that is 29. We can conclude that the mean mark for this group of students is 29. Now moving on to the second tool, it is the median, the true middle. The median can be influenced by unusually high or low values. They are known as outliers. The median gives us the middlemost value of a data set, but after it has been arranged in order. The key idea of the median is that it is a value that lies exactly in the center of a data. Now, we are going to split this into two parts, the median for odd number of values and the median for the even number of values. Let's suppose n is odd. That means we have numbers like 7, 9. So that means the median formula for the median will be n plus 1 divided by 2. This will show us the position, which is in th. For example, we have values 1030, 1050, 1075, all the way up to 2050. So what can we do here? We can find out the value of n, which is the number of values, and add that with 1, divide that with 2. So we know that our median for the odd number of values will be the fourth position. So looking at this data, the fourth position is 1090. So that will be our median. This is our fourth value. And keep in mind that it needs to be arranged in order, either descending or ascending. Now for the even number of values. If n is even, then the median will be the arithmetic mean of the two middle values. That means you can write it as 1 by 2 bracket n by 2 added with n plus 2 divided by 2. Here n divided by 2 and n plus 2 divided by 2 both represent positions in th. For example, we have some values like 35, 35 again, 40, 45, 50 and 60. So we need to check their number of values, that is 10. So that means we have an even number of values. And their median will be used by the formula 1 by 2 bracket n by 2 plus n plus 2 divided by 2. So we get their positions and then we can easily determine what their median is. So that is 42.5. The median for group data, deconstructing our formula. To finding out the median in the group data, we first identify our median group and then we can apply a formula to pinpoint the value. The first step, we need to find the location of the median value. So we will use the formula of n divided by 2. This will show us the position. And we know that n, which is the number of values, it is equal to the summation of x, the sum of all frequencies. The second step is to use the cumulative frequency column to find the class interval where this value lies. This will be the median group. So this is our formula for finding median of group data. It is L plus H over F into n by 2 subtracted from C. Now what do these variables mean? L is basically the lower class boundary of the median group, while H is the size of the class interval, F is the frequency of the median group, N is the total frequency or the number of values, and C is the cumulative frequency of the class preceding the median group. That means the frequencies of the previous classes. Now, how can we calculate the median for group data? Let's look at this problem. Here we need to find the median marks obtained by 100 students. We have our class interval and our frequency. But first we are going to find the class boundaries. Looking at the first class, we have the lower class limit as 10. Subtracting zero point 0.5 from that, we get 9.5 and adding zero point 0.5 to 19.5, that gives us 19.5. So that is our class boundary. Then we're going to do the same for all of the classes, and then we are going to find the cumulative frequency. Looking at the first group, we have the cumulative frequency of 5, the second is 30, the third is 70, the fourth is 90, and the fifth is 100. Now, how can we calculate the median? The first step is to find the median value location. So we know that we have 100 students. We will divide 100 with 2. So that is the 50th value. But we can't see any 50 here. If you look at the cumulative frequency, the first it is less than 50. The second is also less than 50, which is 30. But the third, that is above than 70. That means that this will be our median group, and the preceding classes which are before them, they are going to be the cumulative frequency. Now, step number 2, we know now that our 50th value lies in the 30 to 39 group, since the frequency, cumulative frequency up to the previous group is 30 and up to this group is 70. So now we can easily find the values from our formula from the previous slide. The lower class boundary will be 29.5. Our class interval size will be 30 subtracted from 20, which is 10. Our frequency will be 40. The number will be 100. And our C, which is our cumulative frequency, it will be of the preceding class, which is the class before. So that is 30. Now we are going to just simply calculate. We can write L plus H by F into N by 2 subtracted from C. So 29.5 gets added with 10 divided by 40 multiplied by 100 divided by 2 and subtracted from 30. So we get 29.5 added with 5, that is 34.5. That will be our median for the group data. Now tool number 3, this is the mode and it is the most popular tool. Sometimes the most useful measure is simply the value that appears often. This is the mode. So the mode is the most frequent or repeated value in a set of data. Here we have an example. We have a shoe store, and a store sold the following number of pairs according to their size. For example, for size 6, they sold 14 pairs. For size 7, they sold 25 pairs. On the x-axis, we have plotted the number of pairs, while on the y-axis, we have the sizes. Now the average shoe size, which will be the mean, it isn't very useful for managing our entry, but what matters the most is the size sold here. If you look at the size that is sold the most, that is size 9. Why? Because it has been sold 50 times, while the others have been sold 14 times, 25 times, 45 times, and 30 times. They are all less than 50. Understanding the mode in group data. Unlike the mean and median, a data set can have more than one mode. So a data set can consist of one mode, two modes, and three modes. Now, what is unimodal data set? A data set with only one mode. Example, if you look at this ungrouped data, we have 30, 25, 40, 30, 45, 25, 30, 40, and 30. How many times did 40 appear here? 1, 2, 3, 4. While the other numbers must have appeared one or two times or not even at all. So that means we have only one mode here. It repeated the most number of times. Now, what is a bimodal dataset? It is a dataset with two modes. So if you look at this ungrouped data, we have 1, 2, 3, 2, 1, 3, 1, 2. 1 and 1 appeared two times, 2 and 2 appeared two times. That means we have two modes that appeared the most two times. Trimodal dataset. A trimodal dataset is a dataset with three modes. Looking at our ungrouped data, here we have 125, 130, 115, 125 and so on. So we need to check which of the values all appeared more than one time. And if they are the same, like we have 120 and 125, they appear twice. So that means these are two modes. Then the third value, which is 130, it also appears twice. So we have three modes in our data set. An important note to know is that if each value occurs the same number of times, then the data has no mode. An example of this data set is 1, 2, 3, 4, 5, and 6. All of the values are occurring the same number of times. That means the value has no mode. What is the mode for group data? For group data, we need to find the mode by first identifying the model class. Now, what is model class? It is the class interval which has the highest frequency. And then we are going to use this formula to estimate the exact model value. L is the lower class boundary, while Fm is the frequency of the model class, or in a sense, the highest frequency. F1 is the frequency of the preceding class, which means the class before, and F2 is the frequency of the following class, which means that after our model class, the following frequency. And H is basically the size of our class interval. So here our formula is L plus Fn minus F1 divided by 2Fn minus F1 minus F2 into H. Calculating the mode for group data. Here we have a problem and we need to find the mode of the distribution of the factory workers' wages. The wages which are in rupees, they are our class interval. The number of workers will be our frequency, and then we need to find our class boundaries, which you guys must already know. Now, how will we know what is the model class? We are going to check which class interval has the highest frequency. So the first class, it does not have the highest frequency, neither the third or the fourth. So the highest frequency class is just the second class, which has a frequency of 20. So we can say that our highest frequency is 20, so our model class will be 40 to 44. Now that we know that this is our model class, we can pick out values for our formula within this class. Our L, which is our lower class boundary, it will be 39.5. Our model frequency will be 20. Our frequency, which is the preceding one, it will be 8. And our following will be 6. While our H, which is 40 subtracted from 35, it will be 5. That is the size of class interval. So now we have identified the values, we can just use the formula. We can write 39.5 added with 20 subtracted from 8 divided by 2 into 20 minus 8 minus 6 into 5. That gives us 39.5 being added with 2.31. So that is 41.81 rupees. This is our mode for group data. Now, what is the weighted mean? Sometimes we need to find the average of values that are not equally important. In these cases, we assign weights. They are used to express the relative importance and calculate the weighted mean. If you look at this formula, we have x bar subscript w. W here denotes the respective weights of our value x. And the formula for the weighted mean, it's the same as the formula we used for arithmetic mean. But instead of just adding the summation of x, we add summation of wx, which means the value of x will be multiplied with the respective weights divided by the summation of w. Here we have an example. The impact of a price change in food is much greater than one in miscellaneous. Here we have the items which our food, house rent, clothing, utility bills, etc. Here we have the expenditure which is given in the value. So this will be our frequency. So we can just say that that is our class or that is just x. The weights are given. So when the weights and the expenditure, suppose x is given, we will multiply both of them. So we get wx. Now if we add all of the values that we achieved of wx, we get the summation of wx. And adding all the values of w, which is the weight, we get the summation of w. So now after achieving and identifying the values, we can use the formula, which is summation of wx divided by summation of w, placing the values 220900 divided by 43. we get 5137.21. How do these tools relate? Finding their empirical relation. The mean, median, and mode are distinct measures, but for many data sets, specifically for moderately skewed distributions, they share an approximate relationship. This is known as empirical relationship. If you know any two of the measures, you can estimate the third by using this formula. Mode is equal to 3 median minus 2 mean. This relationship provides a useful check on your calculations, and it deepens our understanding of how the center of a distribution behaves. We have alternate forms. Median, it is equal to 1 by 3 into mode plus 2 mean, and mean is equal to 1 by 2 into 3 median minus mode. The measure of mean, which is x bar, the idea, it is the average value, the balance point of the data. When do we use mean? We use it for symmetrical data where every value is important. But what is the key weakness of means? It is highly sensitive to extreme values or outliers. The second measure which we talked about in this lecture was median, denoted by x tilde. It is the middlemost value. It splits our data set into two equal halves. When to use it? We use it for skewed data or data with outliers or extreme values, when you need the true midpoint. But its weakness is that it can be less representative if our data has very large gaps. Mode. Mode is the most frequent value, the most popular or common item in our dataset. When to use mode? For categorical data or when identifying the most common outcome. And what is the key weakness of mode? It may not exist, or there may be multiple modes. And there you have it. You just mastered the theory of central tendency. If you have a set of data where the mean is 10 and the median is 12, then what is the mode? Use this empirical relation and drop your answer in the comments. Subscribe to STEMBridge for our next video where we solve these live. See you in the next lesson.